In 2017, something quietly happened in a research paper that would end up changing the world. The paper was titled, "Attention is All You Need," published by a group of researchers at Google. It didn't come with a flashy launch, no product, no keynote, just an idea, a new model architecture for machine learning. That idea, the transformer. Today, transformers power everything from ChatGPT to Google Translate to DALL to GitHub Copilot. They're the beating heart of modern artificial intelligence. But what exactly is a transformer model? And why did it transform AI as we know it? Let's break it down, without drowning in math, and with some famous examples that show how this one model changed the game. From sequence to revolution. Before transformers, most language models relied on something called RNNs, recurrent neural networks. Imagine reading a sentence word by word from left to right and trying to understand the meaning based only on what came before. That's how RNNs worked. They had memory, but it was sequential and slow. Then came LSTMs and GRUs, more advanced types of RNNs, better, but still slow and limited. The transformer flipped that on its head. Instead of reading sequentially, it looked at the entire input at once. It didn't just remember the past. It saw the whole picture. The magic? A mechanism called attention. Attention is all you need. Attention is how the transform decides which words in a sentence matter most, relative to each other. Take the sentence, "The cat sat on the mat because it was tired." What does it refer to? The cat, right? A transformer learns to assign attention to the word cat when interpreting it, because that's what humans would do. And it does this not just for one reference, but for thousands in parallel. This ability to attend to different parts of the input all at once made the transformer incredibly powerful for language tasks, and not just fast, but scalable. Why it took over the world. Here's the turning point. Once transformers proved effective, researchers scaled them up, and up, and up. BERT, GPT-2, GPT-3, GPT-4. All built on the transformer. These models started generating coherent paragraphs, translating languages fluently, writing code, answering questions, and in some cases, outperforming humans on benchmark tests. Why? Because transformers handle long-range dependencies, understanding context across paragraphs, train efficiently on massive data, work well in parallel, great for GPUs and TPUs, generalize to multiple tasks. They weren't just better, they were foundational. This is why the term foundation model emerged. Models so general, they could adapt to almost any downstream task with minimal tuning. A real-world analogy. Think of the transformer like a group chat. Each word in a sentence is a participant. Everyone's talking at once. But each message is filtered by relevance. Some words listen more to others, depending on context. This is attention. And this parallel processing, everyone talking, everyone listening, is what makes the transformer so fast and so contextually aware. Compare that to an RNN, which is like a one-on-one phone call. Slower, one word at a time. Memory fading with each step. No wonder transformers won. The rise of GPT and beyond. In 2018, OpenAI released GPT, Generative Pre-trained Transformer. It was trained on a large dataset and fine-tuned for specific tasks. The magic? GPT used something called auto-regression. It predicted the next word, then the next, then the next, like a human writing a sentence. GPT-2 scaled this up. GPT-3 went massive. And GPT-4 even more refined. ChatGPT is a fine-tuned version of GPT designed for dialogue. It remembers, adapts, reasons. But at its core, still a transformer. Beyond text, vision, speech, and multimodality. Transformers didn't stop at language. They spread to vision, vision, transformers, speech, whisper, wavveku, protein folding. AlphaFold uses transformer-based models. Robotics, video, even reinforcement learning. Anywhere data has patterns, transformers find them. And now, with models like GPT-4o and Gemini, we're entering the age of multimodal transformers. Models that process text, images, audio, and video together. This isn't just language modeling anymore, it's universal modeling. The downside, power and problems. Of course, this power comes with cost. Training transformers requires huge computational resources, energy, hardware, data. They also raise ethical concerns. Hallucination, confidently generating false information, bias, learning from biased training data, opaqueness, lack of interpretability. The transformer model isn't perfect, but it's undeniably transformative. The bottom line. So what is a transformer model? It's a deep learning architecture built on attention, capable of learning relationships between elements in a sequence. But more than that, it's the foundation of modern AI. Every time you talk to ChatGPT, translate a sentence, ask your phone for help, or generate an image, you're touching the output of a transformer. And while the math is complex, the idea is beautifully simple. Focus on what matters. Pay attention. Learn what connects. That's what the transformer does. And in doing so, it transforms not just AI, but the way we understand intelligence itself. From linguistics to logic. Why transformers work so well. What makes the transformer so special isn't just its architecture. It's how it mimics human attention. In classical linguistics, meaning comes from context. The meaning of a word depends on the words around it. Transformers capture that principle at scale. They don't just understand word meaning, they understand word relationships across time, grammar, syntax, and even emotion. Imagine reading a novel. The protagonist's name might appear on page 1 and a reference to them again on page 50. A transformer can connect the two. This long-range memory is one of its superpowers. Expert voices. What the AI greats say. Yann LeCun, one of the godfathers of AI, once called transformer. A big step forward in general-purpose modeling. Geoffrey Hinton, another AI pioneer, noted that attention mechanisms help models see the structure behind language. And Sam Altman, CEO of OpenAI, has said, transformers were the foundation that made models like GPT possible. Without them, none of this works. When the experts agree on a breakthrough, you know it matters. The future, where transformers are headed. We're still just scratching the surface of what transformers can do. In 2023, Meta released Llama, a family of efficient transformer-based models, trained with fewer resources but highly competitive performance. OpenAI's GPT-4o, a real-time, multimodal model with vision, voice, and text rolled into one, also a transformer. In medicine, researchers are using transformers to design new drugs by modeling protein interactions. In finance, they're used to detect fraud by analyzing sequences of transactions. In law, they're used to summarize legal contracts and discover precedent. The transformer isn't a tool. It's a new kind of thinking machine. Not conscious, but astonishingly capable. Why it matters to you. Even if you never touch code, you're interacting with transformers daily. Your social media feed, curated by algorithms often built on attention models. Your emails, auto-completed by transformer-powered assistants. Your photos, tagged by vision models built on similar architectures. Understanding transformers isn't just for AI researchers anymore, it's digital literacy for the 21st century. Because this isn't some obscure academic idea, it's the core of the AI revolution. In 2017, "Attention is all you need" was just a paper. Today, it's the blueprint behind the most powerful tools of our age. The transformer model didn't just change machine learning, it reshaped what we believe machines can do. And as the technology continues to evolve, one thing is clear. The future of AI is being built, not line by line, but layer by layer, head by head, attention by attention. And it all started with a simple idea. What if a machine could learn by focusing only on what matters? Now it can, and it does.